Hello and welcome to SudoKanard. We're here to solve this killer Sudoku by Dutch author Richard Stolk, the Sudoku professor. If you're familiar to the channel, you must know that killer Sudoku is one of my favorite variants. And this killer Sudoku is quite difficult, but it's really interesting, as you should expect from Richard. So the rule here is that whenever you have such a cage with a dashed outline, all digits in it should be different, and the sum of the digits is given in the corner. And that's it, and you will find the link in the description. And this is themed around WCPN, which means World Class Puzzles from the Netherlands. And you can see that all regions are shaped after a pentomino. This is the P, this is the W, this is the C, and this is the N. Alright, so where do we start? Well, one place to start is 16 with 6 digits is necessarily 1, 2, 3, 4, 6. That is something that is very useful to know in Kira Sudoku, but I'm not pencil marking 5 digits into those cells. This digit could be found right away by summing all cages and subtracting this from the sum of all digits in the grid, which is 405. I was tempted to do this, but Richard is more subtle than that, so I refrained from doing this and I finally found another option. So what I found is that the sum of all digits here is 39, while I know that the sum of all digits here is 45, which means that removing the common part, this is 6 more than all of that. And the only way of achieving this is by placing a 9 there and 1 and 2 here. This way, those 3 digits sum to 20, that's 29, that's 45, that works. And 20 with 3 digits without using the 9 is 5, 7, 8, and anyway, we already knew that those had to be 1, 2, 3, 4, and 6. Okay, where is the next place to look? We can see that here we are left with 14, which means that those digits here sum to 31, and those digits here sum also to 31 with those 4 digits in common, which means that this digit here is the same as this one. Another way of seeing this could have been to note that those 3 cages overlap completely those 2 regions. And those 4 cages actually sum to 93, while those 18 digits sum to 90, thus having a remainder of 3. And this particular logic can be used elsewhere by noting that there is a lot of symmetry in the grid. So those four cages sum to 107. Those 18 digits sum to 90, which means that the remaining digits sum to 70. They must be 8 and 9. Here, those four cages sum to 100, which means that the remaining sum here is 10 without using those. They can still be 3, 7 or 4, 6. Let's have a look at those two. So we're left with 98 for those 4 cages. Minus 90, that's 8 without using 1 and 2. Those must be 5 and 3. Those must sum to 10 without using 1, 2, or 3. So they must be 4, 6. And the middle set is a 7. In the end, we kind of computed the sum of all cages but 4 at a time. 4 at a time. Okay, so now where is the next place to look? And rest assured that I don't remember the answer to that question. So let's have a look. So I think that the logic that I applied here must apply on other places. Let's have a look at this. This has a sum of 43. This has a sum of 45, which means that this is 2 more than this plus that. And the minimum value for this plus that is 4 plus 3, 7, which means that the minimum value here is 9. So 9 is also the maximum value, so that is 9, and that has to be a 4 and a 3, which is really beautiful logic if you ask me. 6 does not appear in any of those cells, so it must be somewhere there. Let's move on with the same logic here. The sum here is 41, which means that those two digits sum to something 4 less than this. So 5 is too high for that. And this is 1 or 2. If this is 1, then this is 8. And if this is 2, then this is 9. And let's finally do this with those two cages. They sum to 47, which means that this plus that is 2 more than that. But this is high. This has a maximum of 9, so this has a maximum of 11 without using this 3. So this must be 1 or 2. So that this is between 9 and 11, 2 more than that, so this is 7, 8, 9. This is not as spectacular as the other deductions. Where do we move on from that point on? Oh, 9 is not here by the rules of the killer, so 9 is somewhere here, and more precisely around here, which means that this is finally 8 and this is 9. And this is now more interesting. The sum here is either 10 or 11. Subtracting 2, this is either 8 or 9. And now we know that this 9 is nowhere in this cage. 9 is not here, so that is 9. Here we are left with 12. Without using any of those digits, which means digits from 1 to 4, 7, 8. 1 to 4, 7, 8. 1 is necessary. I'm writing them down. 1 to 4, 7, 8. 1 is necessary indeed to do a sum of 8. It could be 1. Oh, actually, 1, 4, 7 is the only option. 1, 4, 7 is actually the only option, which means that this is 2, this is 11, so that is a 9, which places the 9 there. Those are 6 and 8. So a sum of 23. Those must sum to 4, 5 without using the 2. So this is 1 and 4. This 8 is not in here, so it joins the 6 there. Here we're left with 2 and 5. That is a 3. Here we need a 5 and a 7. We can check. This is 32 indeed. Here we have a 5, 7, 8 triple in which 8 is there, so that's not 8. Here we have 4 and 3. Those 3 digits must sum to 11 without using the 4 and the 3. I think that the only option is with 1 to 8. 1 plus 10 without using those is 1 to 8. Without using the 1, that would never work. So this is indeed 1, 2, and 8. And with this, we have a triple. 8 is not here. And 8 is not here, so 8 is there. Down there, we get a 1, 4, 6 triple. And there are probably lots of places to look now. 9 is nowhere here. It's not in here, and it's not here. So 9 goes there. Now in this box, 9 is not in here. So 9 goes into this cage, which means that this can't be a 9, that's an 8. And it places this 8, this 6, and this 8. So now I should be able to deduce this, but I don't remember what the computation was. Anyway, 16 is 1, 2, 3, 4, 6. So here we have 5, 7, 9. There's a 9 here. So 5 and 7. Those 4 digits here sum to 24, so that is 1. That's not a 7. This column, this digit is nowhere here. It must be here, so that's a 1, that's a 2, that's a 1, that's a 1, 2, 1. And up there we need the 4 and the 6. And here 3, 5, and 7. 1 here, so those digits must sum to 30, which means 6, 7, 8, 9. 6 goes there. That's a 7, that's an 8. This now becomes 5, 7, 7, 5. Here we need 3 and 4. Here we need 1, 2, and 6. That's not a 1. This 7 is not here. Okay. Down there we need 2 and 5. So we are at 15 plus 9, that's 24. We need another 4 to get to 28. 2 and 4. No, sorry, 9 and 4. And 9 is here, 4 is there. 8 is not in here, so in this box 8 goes there. This is 3, 6, and 7. Those are 3, 6, and 7. I need 4, 5 here, 2 and 3 here. So we're slowly getting there. Perhaps I should address this 26 cage. Those 3 digits sum to 50. So what are the options for this to sum to 15? Well, I think we need to check what works with 4, what works with 6, what works with 4. If I place a 4, I need another 11. Without using 2 or 4, it will be 3, 8, or 5, 6. But if I place a 4, then this contains a 6. So 4 comes with 3 and 8. That seems to work. If now I place a 6 here, I need another 9 here without using 2 or 4, 6. without using the 4, which is here, which means 1 and 8, but this is not possible because of that. So what I was saying is with a 4, those must sum to 9 without using the 2 or the 4, without using the 6. So they must be 8 and 1, which is impossible. So this was actually 6. That was that the 6. No, that was a 4 with 3 and 8. That's the only option. So this part was quite technical. But this is something you might encounter in a difficult Kira Sudoku. But note that it wasn't about exploring a million of possibilities. And by this, I mean not even 5 or 6 possibilities. It was just 2 options to explore. So now it resolves quite a number. It disambiguates quite a lot. Here, 2, 4, 6, 4, 5, 3. Alright, now this must be a 5, which means that this is 2, this is 5, this is 7, this is 5. Here we need 2 and 7, which places the 7 there. Here we need 2 and 6, so that's a 2, that's a 6. It disambiguates basically everything. This column needs a 3, it disambiguates the rest of everything. That's a 1, that's a 4. And this is it for this really well constructed, but somehow pretty difficult Kira Sudoku by the Professor Richard Stolk. Thanks for watching this video. See you soon on SudoKanard.